I'm going to introduce complex numbers by using a quadratic equation. So ax squared plus bx plus c is a general form of a quadratic equation. To solve this, we would normally use the quadratic formula, which is x equals minus b plus minus square root of b squared minus 4ac on 2a. From our past studies, we should know that the number underneath the square root is the discriminant. If the discriminant is greater than 0, then we know that there are two real roots. If the discriminant is equal to 0, we know there is one real root, or you could say two repeated roots. And if d is negative or less than 0, we know that there are 0 real roots. When studying complex numbers, we're going to learn that 0 real roots is the same as 2 complex roots. So they're not real roots, but we call them complex. I'll show you an example of a quadratic equation which might have complex roots when the discriminant is less than 0. So x squared plus 3x plus 4 equals 0. Trying to solve this, x equals minus 3, which is minus b, plus minus 9, which is b squared, minus 16, which is minus 4ac, on 2a, which is 2. Simplifying it is minus 3 plus minus the square root of negative 7 on 2. So in the past, we would have just said that there was 0 real roots because the number underneath the square root is negative. But now I'm going to introduce some new notation which will help us solve this equation. So we're going to let I equals the square root of negative 1, and if we square both sides, we'll get I squared equals negative 1. These two expressions are really important, and we're going to continually use them over and over again in complex numbers. Today though, to solve this equation, we're only going to use this first one here. So how do we express the square root of negative 7? We rewrite the square root of negative 7 as the square root of negative 1 times the square root of 7, which gives us I, because the square root of negative 1 is equal to I, times the square root of 7, and we rewrite that as root 7i. So from above, our answer now is minus 3 plus minus root 7i on 2. I'm going to split this fraction apart and have minus 3 on 2 plus minus root 7 on 2i. And this represents the two complex solutions. The reason I split it apart is so I can clearly see two components. There's one component which is just a real number, and we call that the real component. The component over here, plus minus root 7 on 2, is next to the I, and we call that the imaginary component. And so a complex number has a real component and an imaginary component. And the complex roots here are minus 3 on 2 plus root 7 on 2i, or minus 3 on 2 minus root 7 on 2i. And these are the solutions. And I'll leave it there.